Have you ever stepped outside on a clear moonless night far from the glare of city lights and just looked up? You see a velvet black canvas sprinkled with a few thousand twinkling points of light. We call them stars. It's a peaceful, beautiful, deeply familiar sight. But, have you ever stopped to think about what you're not seeing? You're not seeing a sky blazing with the light of a trillion suns. That simple, obvious fact, the darkness between the stars, hides one of the most profound questions in cosmology. It's a cosmic detective story. The first clue is the darkness itself. A paradox that puzzled some of the greatest minds for centuries. Why should it be bright? If the universe is infinite and filled with an infinite number of stars, scattered more or less evenly through space, then something strange should happen. No matter where you look, your line of sight should end on the surface of a star. A nearby star, bright and bold. Or a star so far away it's just a faint speck. If stars stretch out forever, every point in the sky should be a star. The celestial sphere should be a continuous, blinding sheet of light. So the real question, why is the night sky so dark? That simple observation contradicts a plausible conclusion about the universe. The darkness whispers that our basic assumptions might be wrong. It's a silent announcement. The universe is more complex and mysterious than we thought. Let's break down the logic that leads to this baffling conclusion. Imagine you're standing in the middle of a truly infinite forest. The trees are scattered randomly, but on average, they are spread out evenly. Now, look in any direction. What do you see? Your line of sight might travel a short distance before hitting a nearby tree trunk. Or it might travel for miles, zipping past thousands of trees before finally hitting the trunk of a very distant one. But in an infinite forest, your line of sight must, eventually, end on a tree. There is no direction you can look where you see an empty clearing that goes on forever. Every possible sightline ends with bark. Now let's trade that forest for the cosmos. The trees are now stars. The universe, according to the science of the 19th century, was thought to be static, not expanding or contracting, and infinite in both age and size. And observations suggested that stars were, on a large enough scale, scattered pretty uniformly throughout space. So, just like in our infinite forest, any line of sight you could possibly pick from Earth should sooner or later terminate on the surface of a star. The entire celestial sphere should be a mosaic of stellar surfaces, all packed together, creating a sky that glows with unimaginable intensity, day and night. You might argue that distant stars are fainter, and that's true. A star that is twice as far away will appear 4 times dimmer. This is the inverse square law of light, a fundamental principle of physics. However, the geometry of an infinite universe perfectly cancels this out. Confronted with this stark contradiction, 19th century astronomers and thinkers did what good scientists do. They tried to find a flaw in the reasoning or an explanation that would resolve the paradox. One of the most popular and intuitive ideas was cosmic dust. Perhaps, they suggested, the universe is filled with vast clouds of interstellar dust and gas that block the light from the most distant stars. This seems logical at first. We know such clouds exist. We can see them as dark nebulae, silhouetted against the bright backdrop of the Milky Way. Surely, over immense cosmic distances, this dust would absorb the light, acting like a cosmic fog and preserving the darkness of the night. However, this explanation has a fatal flaw. What happens to something that continuously absorbs energy? It heats up. If these dust clouds were absorbing the light from an infinite number of stars over an infinite amount of time, they themselves would eventually become incredibly hot. They would heat up until they reached the same temperature as the surfaces of the stars, whose light they were absorbing. And once they reached that temperature, they would start to glow. They would radiate their own light, shining just as brightly as the stars they were obscuring. The dust wouldn't solve the problem, it would just become part of it. The sky would still be ablaze. Another attempt to solve the paradox was to challenge the idea of a uniform distribution of stars. What if we live in a large cluster of stars, and beyond that is just an infinite empty void? Or perhaps the stars are arranged in a fractal pattern, where the density of stars thins out as you look at larger and larger scales. This was a clever idea put forth by some, suggesting that our island of stars is finite, and the light from other incredibly distant islands just hasn't reached us or is too sparse to matter. This would mean that most of our lines of sight would indeed peer into an empty blackness between star clusters. But this solution felt more like a philosophical dodge than a scientific one. It violated the cosmological principle, the The idea that the universe, on a large enough scale, is the same everywhere. While we couldn't prove it at the time, assuming our little corner of the cosmos was special seemed unlikely, and, frankly, a bit arrogant. It was a return to a pre-Copernican way of thinking, where our location was unique. The paradox remained stubbornly in place, a cosmic thorn in the side of astronomers. The simple, elegant, and wrong answers had been tried and found wanting. The real solution would require a revolution in our understanding of reality itself. The true resolution to Olber's paradox didn't come from a new telescopic observation but from a radical, new understanding of the universe. The first piece of the real answer is staggeringly simple. The universe is not infinitely old. It has a finite age. Our universe began in an event we now call the Big Bang, approximately 13.8 billion years ago. This one fact completely changes the game. It means that light, which travels at a very fast but finite speed, has only had 13.8 billion years to travel through space and reach our telescopes on Earth. The darkness we see in the night sky is in part the shadow of the future. Think about it this way. When you look up at the night sky, you are looking back in time. But what lies beyond that? Is there a star whose light has been traveling for 15 billion years? No, because the universe didn't exist 15 billion years ago. There hasn't been enough time for that light to get here. This creates what we call a cosmic light horizon, or the observable universe. It's a spherical boundary centered on us, representing the maximum distance from which light has had time to reach us since the beginning of the universe. The radius of this sphere is roughly 13.8 billion light-years. Any star or galaxy that exists beyond that boundary is, for now, invisible to us. Its light is still on its way. Therefore, when we look out into the blackness between the stars, we are not looking into an empty void. We are looking at a region of space so far away that its light has not yet completed its epic journey to our eyes. So, one of the key assumptions of Olber's paradox, that the universe is eternal, is wrong. The universe had a beginning. This single fact goes a long way toward explaining the darkness. The finite age of the universe is a huge part of the solution, but it's not the whole story. There's a second, equally mind-bending piece of the puzzle discovered by Edwin Hubble in the 1920s. He found the universe is not static, the universe is expanding. And the farther away a galaxy is, the faster it moves away from us. This expansion gives the final knockout blow to Olber's paradox. It does so by literally stretching light until it becomes invisible. This stretching is called redshift. It's like the Doppler effect with sound. Ambulance approaching, sound waves compressed. Pitch, higher. Ambulance receding, sound waves stretched. Pitch, lower. The same happens with light. A distant galaxy speeding away, its light waves are stretched. That shifts the light toward the red end of the spectrum, into infrared, microwave, radio waves, invisible to our eyes. This is the nail in the coffin. The most distant objects are moving nearly at light speed. Their light is so redshifted it has lost almost all energy. This is not a theory. We've observed it. We built telescopes to detect that light. It's called the cosmic microwave background radiation. That ancient, stretched-out light fills the entire sky. In a way, the sky is glowing. But expansion redshifted that glow out of the visible into microwaves.